Hello everyone, welcome back to my YouTube channel Rahman Chemistry Coaching Academy. I am Dr. Tajur Rahman and this is my second lecture on stereochemistry. In our today lecture, we will discuss and explain different kinds of isomerism. There are two types of isomerism, that is structural isomerism and stereoisomerism. Structural isomerism is further classified into six types. They are chain isomerism, functional group isomerism, position isomerism, metamerism, tautomerism, and ring chain isomerism. While stereoisomerism is further classified into two types, conformational isomerism and configurational isomerism. Configurational isomerism is subdivided into two types, that is geometrical isomerism and optical isomerism. Now we will discuss and explain these different types of isomerism one by one in detail. Let's first we get started with structural isomerism. In structural isomerism, the isomers have the same molecular formula, but they have different order of connectivity of atoms. For example, butane, which has two isomers, that is n-butane with straight chain formula, and isobutane or 2-methylpropane with branch chain formula, in which one methyl group is attached to carbon number 2. This is carbon number 1 and this is carbon number 2, and this methyl group is attached to this carbon number 2. So these two isomers of butane have the same molecular formula, they have the same number and kinds of atoms, but they differ from each other in order of connectivity of these atoms. And hence these two isomers are known as structural or constitutional isomers of each other. It may be noted that there are enormous number of possibilities for branching in homologous series of alkane, except the first three members of alkane series, that is methane, ethane, and propane, in which within the compound branching is not possible, and hence they all have no other isomers except the compound itself. These are the first three members of the alkane series: methane, ethane, and propane, and these are the isomers of these compounds. On the other hand, other members of the alkane series, that is butane, pentane, and hexane, have 2, 3, and 5 isomers respectively. These isomers are shown in tabular form. This is butane and it has these two possible isomers. This is pentane and it has these three possible isomers. And this one is hexane, and hexane have these five possible isomers. It may be noted that larger the number of carbon atoms in a molecule, greater will be the number of its isomers. For example, this is an alkane with molecular formula C818, and it has 18 possible isomers. This one with molecular formula C10H22 has 75 possible isomers, and this one alkane with molecular formula C40H82 has roughly 620 into 10 raised to power 13 possible isomers. So this data shows that with the increase in number of carbon atoms, the number of the possible isomers of these alkane increases. This is another table which show the number of the possible isomers of alkane from molecular formula C7H16 to C40H42. These are the molecular formulas of alkanes and these are their possible isomers. This data show that with the increase in number of the carbon atoms in these alkanes, the number of the possible isomers of these compounds increases. The constitutional isomers have different physical properties. They differ from each other in their physical properties like melting point, boiling point, density, and index of refraction. The detailed comparison of the physical properties of butane, pentane, and hexane isomers are shown in tabular form. This is butane and it has these two possible isomers and these are the physical properties of these two isomers and these physical properties are different from each other. This is pentane and it has these three possible isomers and their physical properties are also shown here and these physical properties of these three isomers are different from each other. Same is the case with the hexane. Hexane have five possible isomers and these are their physical properties and this data show that these five isomers of hexane are different from each other with respect to difference in their physical properties. Finally, it can be concluded that structural or constitutional isomers have the same molecular formula, same number and kinds of atoms, but they are different from each other in order of connectivity of atoms. Due to this difference in order of connectivity of atoms, they have different physical properties. So this was all about structural or constitutional isomerism. Thank you for watching my video lecture. Please don't forget to like, comment, share and subscribe my channel.